Hello everyone, my name is Jesus Guzman, currently at Dallas College for Math 1350 and 1351. The topic of discussion for today is the distance formula. The distance formula is a way for us to figure out the distance between 2 points on a graph. Of course, given that we know those points and coordinates on the graph. I chose this topic of discussion, one, because of course we learned that through our course here this semester at Dallas College, but I did find a liking to the formula itself. It's very, very self-explanatory, and as long as you're writing down step by step what procedure you are on and make sure you're annotating everything and not leaving anything out of that equation, it can be very, very straightforward. But also, if you're not paying attention to your integers and values inside that formula, it can also give you a ruse and give you the wrong solution for the equation. So I did choose this because we did discuss this during our course here at Dallas College. One of the things that I really like about math is it makes sense. And if it doesn't make sense, then you know it's wrong. So I think that's what I like most about math is when you got it, you got it. When you don't, you know you don't got it. There's no self-doubt. The least favorite thing that I like about math, the thing I dislike the most is that it is very, very specific on details. So attention to detail is very crucial when handling and dealing with the distance formula. So here shortly, we are going to go over an example and together, and then kind of go over how to figure out the distance between 2 points on a graph, the distance formula. All right, so as you can see, we have the distance formula laid out. Distance formula is as follows. For the sake of the problem, we are going to do A and B for the points. So A and B equals square root of, and then of course in parentheses, x1 minus x2 squared plus y1 minus y2 squared. Now the really great thing about this formula, which is almost the solid reason why I chose this, is the items in parentheses are being squared, which means it really doesn't matter what sign or value it has. It will always multiply by itself and become positive. So just here in the parentheses and here, and then you'll see here in one of our following examples on how that applies and kind of simplifies things for you. Now, of course, we always want to annotate everything for whatever problem we are trying to solve. So regardless, we are still going to practice our good math etiquette and go as follows. First question is, find the distance between, and we're giving 2 points, 2, 5, and 6, 8. Now, first what we need to do is we need to identify our x's and y's. And so realistically, it doesn't really matter which ones we identify as long as we have, we know that this first number here is x, and then the second point or coordinate is y, x, y, which is normally how a point is elaborated and described. So we're gonna put that into our formula. As you can see, square root, and then for the value of x1, we did 2. For the value of x2, we did 6. Notice how we stayed away from our y's. Plus, now we do our y1 plus y2. So 5 would be here in this position, and then our y2 would be 8. Now, of course, remember, always hold the value of whatever numbers you're inputting here, and make sure you write that down so you don't forget. Now, of course, both parentheses are squared, which is why we talked about our big rule and how that benefits us. So here, as you can see, we ended up with -4 squared plus, hold your plus sign, 5 minus 8 is -3 squared. Moving on, a negative times a negative is a positive. So -4 times -4 is positive 16. And then that's what I love about the square. Of the numbers in the parentheses being squared is that no matter what, you'll always have a positive integer at the end of it. -3 times -3 will be a value of 9. 16 plus 9 is 25. And we all know what the square root of 25 is. 5, 25. So there you are. Just a quick easy example on how to use the distance formula when given 2 points. Now, since we did an example together, we are going to apply that to what a problem would be regarding a triangle. So we have here, find the perimeter of a triangle with vertices 0, 0, -4, -3, -5, 0. So it looks like we have 3 points on a graph that make up a triangle, and we are trying to see what the distance is for each length, width of the triangle, so we can later on add all 3 sides and figure out the perimeter. So here is our formula for the distance formula being applied for AB. And so what we're going to do is, because we know this is a triangle, we want to see what the distance is for AB, the distance is for AC, and the distance is for BC. 3 different types of problem-solving situations that we have here in front of us. So what we're going to do is we're going to do AB first. So for now, we can ignore C and focus on A and B. As you can see, we focused on our x integers first. 0 and -4 are plugged in here. And so what I wanted to focus on here is, originally the equation is 0 minus -4 parentheses squared, right? Because you have these here squared. And so the rule that we're going to use here, and we'll talk about it here in just a moment, is the leave, change rule. So because you have 2 negative integers put together, we leave the value of 0, change this to a positive, change this to positive. Leave, change. Now, if these were a opposite value, we would still do leave, change. Regardless, you would still end up with the right number. Here on the second part of the parentheses, we have the 0 from the first y, and then y2, which is -3. So again, with that in mind, originally it was written 0 minus -3, and then of course this is all squared, and we're going to do the leave, change rule. Leave, change. So the value of these change because of our rule, and that's how we end up with 0 plus 3 squared. All right, and so now we can move on to our next step. Once we combine 0 plus 4, we have 4. 0 plus 3, we have 3. Don't forget to bring down your squared unit down. 4 times 4 is 16. 3 times 3 is 9. 16 plus 9 is 25. And we have our distance for AB, which is 5. Now we are going to work on BC, so we can ignore A. As you can see, we plugged in -4 here, our x integer or value, and then our second x value is -5. Leave, change, so this 5 becomes a positive since we're going to add what's in the parentheses. Here on our right hand side, we have -3, which is our first y value, minus 0, which is our second c value. Don't forget squared. And then because this is correct and we don't have a plus or a negative, we are good to go there. And so we're going to bring this down. Once we add -4 plus 5, we have 1 squared. -3 minus 0 is still -3 squared. Move on to the next step. Bring 1 times 1 is 1. -3 times -3 is 9. And we have 10. And because we can no longer simplify that, that's going to be our value, square root of 10 for BC. And so now it looks like we just have one final additional step, AC. Now for AC, let me pull that up right there. We're going to grab our first x value, which is 0, and we're working with C, so it'd be -5. -5 here, leave positive, leave, change. This -5 turns into a +5. Wonderful. Now we're going to work on our second set of parentheses. The first y value in A is 0, so we bring that 0. And then the y value for C is also 0. 0 minus 0, 0. So now we have 0 plus 5, 5 squared, don't forget your squared, plus, bring down your plus, 0 minus 0 is 0, squared, 0. All right, so now we have 5 times 5, 25, plus 0, 0, 0. So we still have the square root of 25, which can be simplified to 5. And so now in the end, to figure out the perimeter of our triangle from those 3 points, 5 plus square root of 10, right? 5 square root of 10 plus 5, AC 5. So that adds up to be 10 plus square root of 10, which is the most simplified form for this problem. And that'll be our answer. 10 plus the square root of 10 for the perimeter of the triangle. I appreciate you guys listening in. And I hope you guys learned a little something today, just a little bit about the distance formula and how to go about it.